how y'all doing today? My name is Bernie Thompson, and today we're here to take a look at a 2003 Mazda Protege 5. This Mazda has a problem to where we can crank the engine but it will not start. So the first thing I always want to do is verify the symptom. The vehicle definitely is having a problem. It will crank and it acts like it's trying to start, but it definitely isn't starting. So this engine was replaced by this shop with a used unit. Ever since the used engine has been installed, this vehicle won't start. So the first thing I want to do is I always want to look at the dash and make sure that I don't have any kind of security lockout. That's on any no start that I'm doing. This dash is good and we're not in a security lockout, but I do want to put a scan tool on it and just see if we have any basic codes. Let's go ahead and take care of that. I've got the scan tool connected to this Mazda. So what I want to do is I want to go in and look at the DTCs. Now we don't have any DTCs, and I can also see that the monitors haven't been run. But wouldn't that be what you would expect? The engine has been put into the car, but it hasn't been run. It can't start and run, so it's not going to set codes. So really, a better diagnostic strategy is to grab a scope and get a scope to connect to the engine so we can see what's not there. In other words, if you take a scope and you connect to the input and output sensors, we can see what's wrong right away. It'll be a very quick, accurate way to diagnose this vehicle. So let's go ahead and get the scope. We've gone ahead and we've connected the scope. I have channel 1 on the crank sensor, channel 2 on the cam sensor. Channel 3 is connected to the ignition for number 1 cylinder. Then we have channel 4, 5, 6, and 7 on those injectors, and we've got 8 on the coil fire command for 1 and 4. So now that we've got this connected, let's go ahead and collect the data. Now that we have the eSCOPE connected to this Mazda's engine, we need to go ahead and collect the data. So I want to go to measure and deep record. Now, since I'm going to be in the vehicle cranking it, I need to control it. So I'm going to use my pen to do that. So now let me go ahead and crank it. Now that we have the data on the eSCOPE, we need to go ahead and analyze this data. So this is the data. We can see right here, this is where the cranking event started, and this is where the output from the crank sensor started to be made. This crank sensor is a variable reluctance type. That means that it's using a magnetic field, and as the magnetic field pulls past up and down by the triggers, I'm going to make a voltage. Where these get bigger, that just says the engine was moving faster or trying to start, so the output from the sensor also grows. What I'm first interested in doing is coming in right here. These are my first injector fires, and they should all be banked there. So when we turn these off, we should see all 4 injectors, but we don't. We only see 3 of them. Now, the blue one is right in front of the ignition point. And this is an ignition point, and the blue one's in front of it. That blue one is the number 1 injector. Now the number 1 injector should be right in between those 2 towers, and that would be on the exhaust stroke. Now we see that the blue one moved behind the ignition fire. Here it's before, and here we have a purple after, and here we have the blue before and a purple after. And here we have the blue one in the ignition event as well. And here we have the blue one after the ignition event. So let's go ahead and blow this up because we definitely have a problem. So if we look at this, the crank indexed itself, crank index to crank index to crank index. This is 1 revolution of the crank, this is a second. We can see that the ignition event is 1, 2, 3, 4, 5, 6, 7 teeth. 1, 2, 3, 4, 5, 6, 7 teeth is on the top dead center position, and that's if it's firing at top dead center. I don't have a known good cam and crank on this engine, so I'm not sure where this should be. But basically, if we were looking at this, we would want to bring the cam sensor down, and we can see the cam sensor is falling over here 1, 2, 3. And that's about on the 12th tooth of this. So we both have rising edge, and if we count over, that's about 12 teeth. So I'm not sure if that's right or not, but I know this is getting confused. So the injector is before and after, and neither of those positions are correct. So where this needs to be, let's mark this. And we'll mark this here. We're going to go ahead and mark this. Now each one of these is a cycle. So if I fired here, this is the power, this is the exhaust, the induction, and the compression. Now this blue injector should be right here in the exhaust plane, and it's not. It's over here in the power side, and that's not where this should be firing. So this is definitely confused, and I can see that I only have the blue and white firing here. The other injectors are not firing. And here we went a cycle, and we have the blue and the purple firing at the same time, and we have the blue and orange firing at the same time, and the white and purple and the blue and orange. And now we have all four injectors fire, but again, the blue, which is number 1, and the number 1 ignition strike, now the blue one is firing over in the compression side. It should be over here. So this is out of time. And we can just go through here and we can see how the computer is really confused on what it's doing with the injectors, and it can't find any kind of cycle with those injectors that would be correct. So the problem here is this has something to do with the computer being confused from the cam and crank. Since I'm not sure how many teeth this should be over, I think this should be like 9 or 10, and we're 12. So I'm not really sure, but I know how to figure this out. I want to take a spark plug out, and I want to check the cam timing from an in-cylinder pressure waveform, and I want to see if the cams are out of time. That would give me a much better idea of what's happening with the cam index to the crank. So let's go ahead and get that compression sensor in the cylinder. We're going to use a tailpipe sensor to get the exhaust pushes out of the engine. I've connected a tailpipe sensor into the exhaust so we can get the exhaust pushes. I've connected a 300-pound into cylinder 1, and then cylinder 1's ignition wire, I have a pickup that goes to channel 2, which is red, and then it's terminated. Notice that I have this going to ground. Always make sure that when you take the ignition away using a pressure transducer, always terminate the ignition event so we don't damage a pressure transducer or some electronic component on the vehicle. I've also connected the -30 pressure transducer to the intake manifold so we can get the intake pulse. So let's go ahead and get the data with the oscilloscope. Now that we have the pressure transducer up on the eSCOPE, let's go ahead and analyze the data. I want to take the zoom window. I can see where we have all different placements because the engine is just spinning faster where it's trying to start, and then it's spinning slower as it comes down. So what I want to do is I want to take a couple of these that seem like they're a little bit more even, and we can see by the distance of the tower, this is turning the engine faster and this is moving the engine slower. But the first thing I want to show you is I can see a problem right away. The ignition event for this cylinder is 180 out. It's firing in the middle. it's not firing on the tops. It should be right close to top dead center where that mark is. So that's 180 degrees out. That's not going to allow this engine to fire. So right away we have injector problems and we have ignition problems. The computer is very confused. It's not sure what it's doing here. So what I want to do is I want to go ahead and we want to get the cursors and we want to put a cursor through each tower top. Now is what we want to do is we want to go ahead and mark this. Now this is top dead, bottom dead, top dead, bottom dead, top dead. Now this is the power stroke, this is the exhaust stroke, the induction stroke, and the compression stroke. Now you can see that on the exhaust I'm firing this ignition, but when that should fire isn't there. The ignition should fire at top dead center, and that's not right. So what I want to do is I want to go ahead and we want to turn off some of these other channels because I just want to check the cam timing. Now I can also see that the marker comes halfway down, and if I go about half ramp, these are even. So if I look at these are very even, and that's going to be okay. If they're uneven and the tower is leaning, that would give me an indication I have some kind of leakage. A cam timing that was way out might make these towers lean. Any leaning condition that occurs in this shows that I have a mechanical failure of the engine, but I do not have leaning towers. They're okay. I want to go ahead and I want to take the zoom window and we want to zoom in down here. Now I can see where this is the exhaust pocket right here, and I can see that this is the bottom dead center mark, and that's the 30 and the 60. So the rule of thumb for these is this pocket right here, the bottom of that pocket should be between 30 and 60 degrees, and it is. And then I can come over here and I can see where this came down and I have this hitch right about 30, and this should be 30 to 60, and so I'm basically within that parameter as well. I have okay pressure at the peak, 150 pounds, and the cam timing would appear to be correct. Now I want to do one more thing. We want to go ahead and we want to turn on the pulls. So these are my pulls, and we can see that the poles are changing, but so is, we can see how wide this is and how narrow this is. But we can see basically when this valve opens, I get this drop. And this valve opens and I drop and I get a drop. So what I want to do is we want to go back through here and we want to just sort of see. It's sort of difficult because it's trying to start. And here we have a little bit more even pulls. So let's go ahead and let's just sort of mark these guys right here. We'll go basically through the middle of the tower. And this isn't exactly accurate, but it'll give me an idea so I can show you what I'm looking at. Now, do you see how that drop right there happens at that mark and that mark and that mark and that? These are real even. And when the valve opens right up here, I get the drop. I'm making a pull on the intake pull, and right here that valve opens and I get a drop. And then I pull up and the valve opens and I get a drop. So this is correct, and this also shows me that the intake cam is opening correctly. Now we've already looked at the exhaust and it looks okay. So now we're going to look at the exhaust down here, and we can see to where we have the push, and this, when it's lower, is more vacuum. When it's high, it's higher. And we can see that these are moving through, and these don't look to have a problem right now. So basically, is what this is telling me is the cam timing on this engine is correct. Now the cam sensor is run off of the exhaust cam, and the exhaust cam looks fine. So we can see right here at this pocket, if I take this cursor here and we put it here and we measure this to the pocket drop, we can basically see right here we have 33 degrees. Well, that's within my rule of thumb for my target. So the cams are in time. I don't see the cam being out, but the cam crank correlation is off on this somehow. Something's wrong with one of the target wheels, I believe. So what we're going to need to do is we're going to need to figure out what's going on with the target wheel. So I want to go and talk to the shop and see, since they put the motor in, I need to figure out what target wheel is on this engine, if they changed them or they didn't change them. So let me go see what they have for the target wheels around here. Okay guys, we found the original engine that came out of this Mazda, and we pulled the covers off of it to check the target wheels on the cams and on the crank. And the cam is definitely got a different target to it. So let me show you what the differences are. Okay, here's the pulley we've been looking at the waveforms from, and as you can see, I have a target right here, this bump. And if we look all the way around, there's only one target, and that's what we see on the scope as one target. What the original pulley had on this is it has one target with two more that are 180 degrees out from it. So this is what is supposed to be on the exhaust cam, and therefore we would be reading three targets. So the computer's algorithm is looking for the time between the rise and falls of each one of these bumps to compare it against the crank, and then it's going to figure out where crank angle space is, or which stroke we're on. Without these additional bumps, these target wheels, so the computer has something to work its algorithm with, the computer is just totally confused. So as we can see, this indexing, or the targets on the exhaust cam drive, are very different from the one that's on this engine, and that was causing the problem. So with a very detailed plan that I've laid out for you, you can find a target wheel that's different even though you don't have a known good waveform. There are so many different engines that there's no way that you're going to have every single known good cam and crank. In this procedure, when you use event-driven data where I make a test and that data is driving my next test, you will absolutely be able to see what's going on and what's wrong with the engine, even though you don't know what the cam and crank should be. I've laid out a very good procedure here to how this would be accomplished. You guys need to use scopes. If you don't have scopes, you need to get scopes and you need to start to use them. If you have a scope, start using it more. A scope is the modern technician's tool. It's a window into seeing the electronic side of a car that you can't see with scan tools. Start using your scope and you too will have good diagnostics in your service bay.